Lesson 6.5 is graphing polar equations. And we're focusing on the basics of graphing polar equations, but when I'm talking about graphing polar equations, I'm not talking about graphing it with the calculator. I'm talking about graphing it by hand. And when we don't know what something looks like and we go to graph something by hand, what's our technique? To use I call them XY charts. Some people call them T charts. In this case, it's not going to be an XY chart. It's going to be a theta R chart. Okay. Similar idea. And so that's what we're going to practice doing. Now, I am not against you using the calculator as a check because it is sometimes interesting to figure out how the points connect. Okay. So you see kind of big theta R charts, but we're going to go through and work on filling these in. This is why I said you need a calculator. Not for the graphing purposes, but some of these are values that you may or may not know, or we may want a decimal version in order to graph it. So let's look at this. Our first equation that we are going to graph is that of R equals sine theta. Now, in rectangular coordinates, we know what sine theta looks like, right? That is the curve that starts at the origin, goes up, crosses back through, and then goes down and comes back up. We're looking at polar coordinates, so work with me here. Some of these you should know without putting them in your calculator. So if we put 0 in for theta, nothing fancy here, just what is sine of 0?
0.
Sine of 0 is 0. Okay. And you can get that by thinking about the graph or looking at the quadrantal angle. What is sine of pi over 6? 1/2, which, if you want, based on the fact we're going to be graphing this, you can think 0.5. What is sine of pi over 4? Okay. Our brain says square root of 2 over 2. Can you get me a decimal approximation for that? Okay. 0.707. So notice when we graph it, we're going to be around 0.7. Okay, what about sine of pi over 3? Square root of 3 over 2?
0.866.
Okay, decimal approximation, 0.866. What about sine of pi over 2? 1. Now, sine of 2 pi over 3. And you guys can always go calculate on these. However, sine of 2 pi over 3. Just realize that takes me at a quadrant 2, yes. What do we know about quadrant 2? Sine is still positive, right? All students, so sine is positive. So 2 pi over 3 is going to be equivalent to the pi over 3 answer. So it's going to be the square root of 3 over 2, or in other words, 0.866. 3 pi over 4 is going to be equivalent to the pi over 4 answer, which is square root of 2 over 2, or in other words, 0.707. Sine of 5 pi over 6 is going to be equivalent to the pi over 6 answer, which is 1/2, or in other words, 0.5. There's some repeating values happening here, aren't there? What about sine of pi? Sine of pi is 0. Again, you can do the calc there, but think quadrantal angles, the ordered pair, -1, 0. Now, as we go down into quadrant 3 here, what do we know about sine in quadrant 3? All students take, so sine is going to be negative. So basically, repeat our same answers from above, but this time we're going to make them negative. So 7 pi over 6 is going to be the pi over 6 answer, but negative. So negative 1/2 or negative 0.5. Sine of 5 pi over 4. That's going to be negative square root of 2 or negative 0.707. Sine of 4 pi over 3. Negative square root of 3 over 2 or negative 0.866. What about sine of 3 pi over 2? Am I going too fast? I still see people writing, I guess.
-1.
Negative 1? Because on the quadrantal angle, it's the ordered pair 0, -1. So there's -1. Then we got one last quadrant's worth. Quadrant 4, all students take calculus. So sine again is negative. And again, okay, 5 pi over 3, that's the pi over 3 answer, but negative. So negative square root of 3 over 2, negative 0.866. Sine of 7 pi over 4 is the negative square root of 2 over 2, or negative 0.707. Sine of 11 pi over 6, negative 1/2, so negative 0.5. Sine of 2 pi. Circles back to be the same as sine of 0, right? Basically, we have all the basic pieces of our unit circle up through 2 pi. Okay, so unfortunately, it's not like an XY chart where you can just do 0, 1, 2. 3 points isn't going to cut it. On 2 of the problems in homework 1 and 2, they give you an XY chart. Or excuse me, an R theta. They give you theta values to use to get your R values. So you can just do those. On the other 4 problems, I'm going to suggest you do something like this. Okay, to get a full idea of what the graph does. Now, you guys have this right in front of you, yes? Because there was no way the way these notes are set up that I could get it all in the bin queue and make it readable. So I'm going to go to my next page because we got to graph this now. Now, before we graph this, should we put some labels on the graph? Always good, yes? Okay, you be the rebel, Jacob. I'm going to put some labels on my graph. So I know that this first piece right here is 0. Then my 3 lines in the first quadrant, pi over 6, pi over 4, pi over 3. At the top is pi over 2. Then I reverse my counting, thirds, fourths, sixths, and it's going to be 2 pi over 3, 3 pi over 4, 5 pi over 6. Those are all just one piece before a full pi. Then, now we're closer to the x-axis, so this time we're going to count 6th, 4th, thirds. And we're going to be all one above pi. So 7 pi over 6, 5 pi over 4, 4 pi over 3. We know down there at 270 we talk 3 pi over 2. And then the last quadrant, we're going to count thirds, fourths, sixths. Sixths are always closest to the x-axis. And these are all going to be 1 before 2 pi. So 5 pi over 3, 7 pi over 4, 11 pi over 6, and please remember 0 is the same as 2 pi. Okay, now, the other thing we're going to do, and I'm not recommending you do this in homework because I don't think you'll need to. If you go back and look at our theta values, excuse me, R values. What is our biggest R value? What's the farthest we're ever going to go out? 1. Farthest we're ever going to go out is 1. I don't know about you guys, but that looks like a very challenging graph to make. So, can we scale this graph? Do you understand what I'm saying here? Instead of making each ring count as 1, could I make each ring count as something smaller? Do you see where I'm going with this? Rather than these rings being 1, 2, 3, 4, 5, 6, 7, 8, 9, and I only ever use one of those 8 rings, let's count by something else. Okay? What are you suggesting? What do you mean 2?
Count by 2s. Can we do that?
You want to just
Count the other way around, yeah.
Okay.
So I thought about counting by quarters. Or, in all honesty, I only count up to 9 there, didn't I? Did I say there's 9 rings?
Yeah.
Because I was going to say we could almost go by tenths. But we can't quite make it there, can we?
So close.
Huh?
So close.
Well, we can try it by tenths, and just the last dot's going to be 1 ring out. You want to try that? Let's try it. It's an experiment. Sorry, guys. You were in my experimental class today. So, now, and it doesn't really matter where we count, but so basically what we're saying, I'm going to move this over then, is that the first line is going to be 0.1. The next line is 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and where's 1 going to be? The invisible ring out there. Maybe I shouldn't do that whole invisible ring thing, but we are. Now, because it was going to get kind of dicey labeling, I labeled every other line. You can also label every line. But in order for it to be scaled, you have to label, yes? Because otherwise, I'm assuming each ring counts as 1, not more than 1. Make sense? Okay, are we ready? Let's graph. You guys have your theta r values up top, yes? 0, 0. You got that one? We got a dot at 0, 0. Pi over 6, 1/2. So pi over 6, comma 0.5. So what am I doing? I'm going to go to my pi over 6 angle and go out to where? 0.5. Pi over 4, 0.7. So I'm going to go over to my pi over 4 line. And I'm basically going to go, I would just put it at 0.7, honestly. Is what, it's 0.707. That's pretty much 0.7, isn't it? Pi over 3. I'm going out to 0.866. So my pi over 3 line, 0.866 is what? In between 0.8 and 0.9? A little closer to 0.9? Are we okay with what I'm doing? Pi over 2 is 1. So basically, I'm going to put my dot. In my brain, my invisible ring is at the end of that line there. That looks about equally spaced. 2 pi over 3, 0.866. So in between 0.8 and 0.9, a little closer to 0.9 than 0.8. 3 pi over 4 is at 0.7. Okay, kind of a challenge to follow that labeled line around, but count carefully, right? 0.7. 5 pi over 6 is at 0.5. And pi is at 0. You got your first half done. Okay, second half. 7 pi over 6. Wait, are we all caught up or no? Holler at me if I'm going too fast. Okay, so 7 pi over 6, negative 1/2. Have you figured that out? 7 pi over 6 is down here, yes. Where's negative 1/2 take me? It's going to shoot me back through the pole and put me at 1/2 on pi over 6. Do I already have that dot? I do. I mean, you can make a dot on top of the dot if you want, but it already is there. What about 5 pi over 4, negative 0.7? 5 pi over 4 is down here in quadrant 3. Where's the negative 0.7 shoot me? Up to the positive 0.7 I already have. Are you seeing a trend here? 4 pi over 3, down in quadrant 3, negative 0.866. Oh, hey, guess what's up already on pi over 3? The positive 0.866. 3 pi over 2, negative 1. 3 pi over 2 is down here. Negative 1 is back up through the top. 5 pi over 3. Can you guess what's going to happen? It's negative 0.86, so we already have it over here on 2 pi over 3. 7 pi over 4 is down here in quadrant 4, but negative 0.7 is up here on 3 pi over 4. 11 pi over 6 is negative 1/2, which is up here on 5 pi over 6, and 2 pi, comma 0. Okay, guys. Now, here's the deal. When you go to connect dots in polar coordinates, connect the dots, assuming you place them in order, like in numerical order, which we did, right? You connect the dots in the order you connected them. And I was just going to double check, because I don't remember exactly. It's a circle type figure, isn't it? Yeah. And yeah, it is a circle figure. So I'm going to start here at 0, and I'm just going to go around and connect. Okay, I slightly missed a dot, but you get the idea. The directions do not read this way in homework, but this is basically what I want you to do on 36, 37, 38, and 39. Okay? The directions read something about analyze it, and if you look in the answer key, they talk about lots of different aspects of the graph. That's not what I'm looking for. I'm just looking for us to get the basic graphs here. Questions on that one? Got it? Okay. Well, shall we try the next one? So I'm just trying to get you some experience checking some of these. So let's go ahead and look at number 2, which means I'm backtracking, so I can go to my XY chart. Excuse me, theta R chart. Generic thing, they're all XY charts. So R equals 2 cosine theta. Notice it's the same theta values as last time. 2 cosine theta basically says we're taking the cosine value from the chart and multiplying it by 2. So what is cosine of 0? Cosine of 0 is, where's my cosine graph start? Starts up at 1, doesn't it? And 2 times 1 is 2. Two times cosine of pi over 6. What's cosine of pi over 6? Square root of 3 over 2. Square root of 3 over 2 times 2 is going to make this square root of 3. Now, you can leave it as square root of 3. However, what's going to be more helpful in graphing? Yeah, you're going to need to think about the decimal, which my brain says 1.7.
Yeah.
I've written down 1.732. In all honesty, 1.7 is going to be enough for graphing purposes, isn't it? So, I mean, if we want a little bit more, the square root of 3 is 1.732. Okay, 2 cosine pi over 4. Well, cosine of pi over 4, square root of 2 over 2, times 2 makes it square root of 2. Square root of 2 is 1.414, correct? Yeah. Cosine of pi over 3. Cosine of pi over 3 is 1/2 times 2, 1. Oh, this is a little bit nicer, right? A little bit bigger numbers. What about cosine of pi over 2? Cosine of pi over 2 is 0. 2 times 0 is 0. Now, do you realize we're going to repeat these answers somehow or another, all the rest of these quadrants? We have our core answers here. It's a matter of knowing which signs to put on them in each of the rest of the quadrants. Are you connecting that? So you can cut yourself a little, shortcuts here. So when I do cosine of 2 pi over 3 times 2, well, it's going to be the same as cosine of pi over 3 times 2. So it's going to be 1. But what do we know about cosine in quadrant 2? All students. And so that makes these cosine values, my next 3 cosine values, negative. Does that make sense to you? So cosine of 2 pi over 3, equivalent to cosine of pi over 3, so we're going to use negative 1. 2 cosine of pi over 4. Or 3 pi over 4, it's going to be negative square root of 2, or negative 1.414. 2 cosine of 5 pi over 6. Well, square root of 3 times 2 with a negative, negative square root of 3. So negative 1.732. Is this making sense? Stop me if you want some more explanation about how I'm doing this. And if you put it on the calculator, you're getting these same decimal values. You are, okay? Just make sure your calculator's in radians, of course. Okay, what do we know about the cosine of pi? Cosine of pi is negative 1 times 2 is going to make this negative 2, I believe. Okay, these next 3 are quadrant 3. What do we know about quadrant 3 in cosine? All students take. So these next 3 are also going to be negative. 7 pi over 6. It's going to be the negative version of pi over 6. So negative square root of 3, negative 1.732. 5 pi over 4. It's that negative square root of 2, negative 1.414. 4 pi over 3. It's going to be negative 1. Okay, what about 3 pi over 2? Cosine of 3 pi over 2 is 0. 2 times 0 is 0. Quadrant 4, all students take calculus. So quadrant 4 are going to be positive values again. So 5 pi over 3 is going to be positive 1. 7 pi over 4 is going to be positive square root of 2, 1.414. 11 pi over 6 is going to be positive square root of 3, 1.732. Cosine of 2 pi times 2. That's going to be cosine of 2 pi is 1, times 2 is 2. Which, that answer should always be the same as 0. Well, yeah, I think it should be. Okay, we ready to graph? You guys have what you need off the chart here? Okay, label your pieces again. So over here we have 0/2 pi. I just put 0/24. I'm not going to ask. So pi over 6, pi over 4, pi over 3, pi over 2. Second quadrant, 2 pi over 3, 3 pi over 4, 5 pi over 6. This one is going to be pi. Next quadrant, 7 pi over 6, 5 pi over 4, 4 pi over 3, 3 pi over 2, straight down, and then last quadrant, 5 pi over 3, 7 pi over 4, 11 pi over 6. Okay. Again, I'm not sure you need to do as much scaling on homework. Not saying you can't, but what's the biggest number we go up to this time? 2. I don't want to make this all fit in those first 2 circles. Trust me. See, I know you guys can't see these notes in pencil, but like, here's my little circle on the first one. Okay? You don't want to do it. So we can't count by tenths this time. I say, what about quarters? Do you like that idea? I like that idea. I like it better than counting by like 2/10. That doesn't. So if I count by quarters, my first ring will be 0.25. My next ring will be 0.5. Next ring is 0.75. Then we have 1. 1.25. 1.5, 1.75, and 2. Did I do that right? Yeah. I'll be honest, I only labeled every other line because it gets hard to get it in there. So basically it's 0.25, 0.5, 0.75, 1, 1.25, 1.5, and 2. Ready to see what this graph looks like? Graph carefully, right? Okay, you guys have your values in front of you. 0, 2. So at 0 radians, you go out to 2. I just put a dot right on my 2 that I just put there. Pi over 6, square root of 3. So on pi over 6, I'm going to go out to 1.7, which 1.7 is going to be basically right on 1.75. Teeny bit before it, but. Pi over 4 is going to be at 1.4. So I'm going to stop slightly before 1.5. Pi over 3 is at 1. Pi over 2 is at 0. Two pi over 3 is at -1. Think carefully here. So 2 pi over 3 is up here in quadrant 2, but -1 is going to shoot us down to quadrant 4. So we're going to be right down here on 5 pi over 3 and 1. 3 pi over 4 is -1.4. So 3 pi over 4 is in quadrant 2. -1.4 shoots me down on 7 pi over 4. 5 pi over 6 is -1.7. So 5 pi over 6 in quadrant 2 shoots me down to 11 pi over 6 and the 1.7 that's right before 1.75. And pi is -2. So pi at the left, well, -2 shoots me through over here on the 0. Are we back to the same point we started at? Yeah. Now, I'm not going to say it's always going to happen this way, but you're going to notice a repeat trend from the first problem, aren't you? Are these points repeating now? Okay, we're still always going to try them because I can't say it will always happen that way because it kind of depends on what other pieces of the equation we have. But as you start looking, 7 pi over 6, negative 1.7. Well, we've already got that point on pi over 6. 5 pi over 4, negative 1.4. We've already got that on pi over 4. 4 pi over 3, negative 1. We've already got that on pi over 3. 3 pi over 2 and 0. We already have our point at the pole. 5 pi over 3 and 1. We've already got 5 pi over 3 and 1. 7 pi over 4 and 1.4. 11 pi over 6 and 1.7. 2 pi and 2. Okay, what's it look like we have again? Look like a circle? I think it's a circle if I recall correctly. I'm struggling to type here. Yep. Okay. Trying to debate which one I want to do of these last two because we're obviously not getting through everything. How about we try number 4? It looks a little more interesting. We're going to skip 3. I don't think. Hold on. Before I say let's skip 3, let me double check something. I didn't assign any with secant, did I? No, I did not. All of yours in homework use sine and cosine. So, I'd rather talk about number 4. Neither of these make circles this time. They're slightly different figures. So, okay, number 4, 1 plus sine theta. So, I'm not going to flip my chart back and forth, but could we go back to number 1 and use those sine theta values and just add 1? It's 1 plus sine theta, right? So, sine of 0 is 0, plus 1 is going to be 1. Sine of pi over 6 is 1/2. Plus 1 is going to make it 1.5. Can I just write it? I think I'm just going to write decimals this time. It's 1.5. Sine of pi over 4 is square root of 2 divided by 2 plus 1. So that's the 0.7 number plus 1. So 1.707. Sine of pi over 3 is square root of 3 over 2, which is that 0.866 number, plus 1 makes it 1.866. Sine of pi over 2 is 1, and 1 plus 1 is 2. Sine of 2 pi over 3 is the same as pi over 3, plus 1, 1.866. Sine of 3 pi over 4 is the 0.707 plus 1, 1.707. Sine of 5 pi over 6 is 1/2, plus 1 is 1.5 or 1.5. And remember, first and second quadrants of sine are both positive, yes? Sine of pi is 0, plus 1 is 1. Okay, we have to think carefully on these next few, because we're not really going to be adding on the next ones, are we? Well, we are going to be adding, but we're going to be adding 1 plus a negative value in these next two quadrants. So when we do sine of 7 pi over 6, well, 7 pi over 6 is going to be the 0.5, We're going to do 1 minus the 0.5, which is going to make it 0.5. That wasn't horrible. Okay. Sine of 5 pi over 4. Well, that's going to be the 0.707. 1 minus the 0.707. I have written down as 0.293. Okay. So already you can tell, oh, we're going to have to graph all of these this time, aren't we? We don't have negatives shooting us through. The 4 pi over 3, well, that's going to be 1 minus the 0.866, so 0.134. Sine of 3 pi over 2 is -1. 1 plus -1 is 0. 5 pi over 3 is going to be the same as 4 pi over 3, 0.134, 0.293, 0.5, and sine of 2 pi is 0, add 1 is 1. I wrote those down quickly because I want to make sure we look at the graph, and we've got 4 minutes. Okay? Get the values you need. Basically, we just repeated the previous quadrant, right? Go ahead and start labeling your graph if you want. What do we go out to 2 here? So I would label to quarters again. So, let's see. Got 0 and 2 pi. Pi over 6. Pi over 4. Pi over 3. Pi over 2. 2 pi over 3. 3 pi over 4. 5 pi over 6. Pi. 7 pi over 6. 5 pi over 4. 4 pi over 3. 3 pi over 2. 5 pi over 3. 7 pi over 4. 11 pi over 6. Because we're going out to 2, I'm going to count by quarters again. So first line is 0.25, 0.5, 0.75, 1, 1.25, 1.5, 1.75, and 2. Okay, we ready? 0, 1. On the 0 degrees, we're going right 1. Pi over 6, 1.5. So on pi over 6, I go out to 1.5. Pi over 4, I'm going out to 1.7, which is right before 1.75. Pi over 3, we're going out to 1.8, which is not all the way to 2. Pi over 2, I'm going up to 2. Two pi over 3, going to the 1.8 value again. 3 pi over 4, it's the 1.7 value. It's right before 1.75. And 5 pi over 6 is 1.5. Oof, follow that circle carefully. It's looking like a circle again, isn't it? Pi is at 1. No. Good, they hung up. Okay, 7 pi over 6. Oh, 0.5. I'm not shooting back through the pole this time, am I? Interesting. 5 pi over 4 is 0.293. So right past 0.25. 4 pi over 3 is what, 0.134? Halfway before that first ring. 3 pi over 2 is 0. And then 0.134, so halfway to that first ring. 0.293 is a little bit past the first ring. 0.5 is the second ring. And then 1. Okay, guys, this picture, and you can look at a better picture. It's not exactly a circle. It goes up in the center at the bottom. I don't have a name for that, but it does, it's kind of circle-like, but then it goes up that way. Okay? Now, pick up a piece of graph paper before you leave, although if you're going to be in here and just want to work on it tomorrow, I guess you can always grab it tomorrow. But A-push kids, definitely pick one up. I haven't tried this graph paper. Hopefully it works okay for you. Feel free to scale if you need to. I'm not saying you'll need to. The first two problems, 1 and 2, they give you a theta r values to fill out. Use their values. You won't, And the other 4, I would use the values we've been doing. Okay? So give it a try. Bring it back Monday.
Sergeant?